some activities in your life that sort of the better you get at them, the more you realize how much worse you are than like the real people who are really good at them, right? That's sort of like characteristic of a fat-tailed distribution of talent, right? A thin-tailed distribution is where you feel at some point, well, I kind of mastered that and that there's all there is to learn. But if you think about something like chess or most academic learning or sports, those are things where like the better you do, the worse you feel. You know what I mean? Whereas something that's thin-tailed is something like where the better you do, the more you feel you kind of mastered it. And there's lots of skills that are like that in life as well, right? So like driving a car, pretty much like you learn how to drive a car, and that's basically all there is. You know, I mean, if you were trying to go into like racing cars, you might feel the opposite way, right? But for like just basic driving, it's not like there are people who are like all that much better than anybody else, right? Whereas these fat-tailed things are like, you know, the opposite way around. And it's similar, you know, if you were trying to be the worst depression of all time, you would probably feel similarly, right? Because you'd say like, oh, I'm starting to get to be a pretty bad recession, but then shit, there's the Great Depression, that's much worse, right? So this is what Nassim Taleb calls the black swan. These fat-tailed distributions also tend to characterize what happens in terms of like stock market movements. So stock markets, like, you know, a bad day in the stock market is a lot better than a really bad day in the stock market. And a really bad day is even like a lot more better than like the worst day ever on the stock market. Right? However, a lot of economic theories often rely implicitly on the assumption that there's thin-tailed distributions. And this is common for many statistical distributions. So like uniform distributions, where you can't be above a certain level. A key thing that's being assumed, and a key thing that drives most of the conclusions that you do based on those, is that they have thin tails. That above some level, like there's not anyone much better than that. And normal distributions are similar in that way. So let me see if I've got a picture of these. Nope, I don't have this for this lecture. Anyway, basically if you look at a normal distribution, it dies off pretty quickly. If you look at something like a log normal distribution or a Pareto distribution, will look like they just stay very, very sort of high, even as you get out way far in the distribution. Yeah, Eric.
Can you draw a fat-tailed and a thin-tailed distribution?
Yeah, let me just switch the other class's slides. Okay, there we go. So here's a uniform distribution. It's big in here, and then it's nothing out there, right? Normal distribution. Big in here, and then very quickly dies off. Log normal distribution. Really slowly dies off, right? So you're like way standard deviations above the mean, and it's still like pretty substantial. You see, that's what makes a distribution fat-tailed. Okay, so, unfortunately for anyone who is hoping to make progress in terms of feeling better about themselves as life goes on, most things indicate that in most areas the distribution of talent is extremely fat-tailed. And in fact, it usually follows what's called a power law or a Pareto distribution. And that has the following form. So X is the talent of a given person. X minimum is sort of like where you begin to get this feeling of insecurity. So like that's like the minimum level of talent where it starts looking like a Pareto distribution. And alpha is something which the bigger it is, the less fat-tailed it is. If alpha is small, then it's very fat-tailed. Okay, so some ways to think about this Pareto distribution are the following. The fraction of people that has talent greater than 2x is 1 over 2 to the alpha of the number of the people who have talent above X. So if alpha was equal to 1, so it's very fat-tailed, the people who are like twice as talented, there's about half as many people who are at least twice as talented as some level. So you lose about half the people when you double the level of talent. So another way of thinking, if you're thinking about it just in terms of money, that would say that the number of people who are earning above $100,000 is only twice the number of people who are earning above $200,000. Or the people who are earning, $8 million a year is only 1/8 of the number of people who are earning above $1 million a year. That's a very slow rate of dying off in terms of people's talent. So a famous implication of this is that if alpha is 1.2, then 20% of people have 80% of all the talent. Another way of thinking about this is that the fifth most talented person will be 1/5 to the 1/alpha as talented as the most talented person. So if alpha is equal to 1, the fifth person is 1/5 as talented as the first most talented person. The second most talented person is 1/2 as talented as the most talented person. So the further you get up the distribution, the further apart people are. So the first person is twice as good as the second person, but the second person is only 3/2 as good as the third person. And the fourth person is only 4/3, the third person is only 4/3 as good as the fourth person, and so forth. Many distributions related to talent follow this distribution. So income, for example, is very well known to have a Pareto distribution at the top end of the spectrum, with alpha somewhere between 3/2 and 3. Probably closer to 1.5, especially in the United States, but in some more egalitarian countries, it's closer to 3. Wealth distribution has an alpha somewhere between 1 and 2. CEO compensation is roughly alpha is 3. One of the most common is Zipf's law, which says again that alpha is equal to 1. So the most talented person is 5 times as talented as the fifth most talented person. I'm going to show some pictures of this, but for 2 cases, but it applies in many cases. So comparative advantage across countries. Japan is about twice as good at producing electronics as Korea is. Korea is about 3/2 as productive as, I guess, Taiwan is probably the next country. And then it falls off very rapidly from there. So Japan is just enormously more productive than our other countries at producing electronics. Words in the English language are like this too. The most commonly used word in the English language is used about twice as much as the second most commonly used word. And the second most commonly used word, and it's about 3 times as much as the third most commonly used word. And about 4 times as much as the fourth most commonly used word, and so forth. And this is true in every language, basically. So here is a remarkable graph. So what this is if you just take any given industry, or if you take all companies in the U.S. and you say, how large are they? How many people do they employ? And then you say, how many firms are there of at least that size? You get, and this is pretty darn amazing. I don't know how many of you guys have ever done any empirical economics. You usually get some giant cloud of stuff, and you say, well, is there a line through that? Maybe. And this is like, this is just a line, right? And it just lines up exactly along that. So this is Zipf's law in action, right? So like the biggest firm has twice as many employees as the second biggest, and 3 times as many as the third biggest, and so forth. And here, maybe even more amazing, is cities. So the biggest city in the U.S., New York, is almost exactly twice as big as LA. And is almost exactly 3 times as big in terms of population as Chicago is. And almost exactly 4 times as big as Houston is, which is the 4th biggest city. And so forth down the line. And this graphs that by taking the log of the population against the log of the ring. That should be exactly -1, should be its slope, and it should fit perfectly as if law holds. And it's pretty darn close, right? Okay. So, this raises a lot of questions that we'll be addressing throughout the course. So one is that rents, even in the long run, are going to be very important. If we're in one of these fat-tailed cases, the differences in talent between the top people and the people below them are just so large that in the long run, there's going to be no way for other people to keep up. And the long-run adjustment is probably going to happen by the superstar effect or things like that, rather than by more firms entering the industry. And this fundamentally undermines the logic of free entry that a lot of economics depends on. And you might actually think that this shows that in intellectual property areas, those are some of the few areas where actually talent can't keep you ahead of everyone else, because it's easy to reverse engineer things. So if you want people to go into developing new products rather than into other areas, it's going to be really important that you give them intellectual property protection. Because otherwise, they're going to go somewhere where their talent can actually make the money that it deserves. So in some ways, you could think that IP, rather than making an unnatural barrier to entry, is actually just reconstructing the barriers to entry that exist in other areas. Another problem that this raises is that if some firms are so much better than others and are going to be so much bigger, that's going to probably give them a lot of market power, unless there are really big diseconomies of scale, and therefore there's a very large number of firms. And you'll look at this on your problem set a little bit. And that's going to raise big problems for thinking that there's a competitive industry. It's going to force us to think about industries with a small number of firms. Also, it says that the income distribution is going to be very unequal. And that might give us reason to want to redistribute income or wealth. And it's also going to mean that raising taxes just on the top incomes can generate a lot of money. Because if 20% of people control 80% of all wealth, right, a lot of the money to be gotten can be gotten out of the top part of the income distribution. And so, in some sense, this is the agenda of things we're going to be looking at during the rest of the course. And I can take questions for 10 minutes, or you guys can just speak. Thanks.